Good evening. My name is Surakshi Bhomik, Department EC, 5th Sem, 3rd year. Today my topic is pulse code modulation. Introduction. Pulse coded modulation, commonly called on PCM. It is a technique used for representing the analog signals such as speech or music or sensor, output or installed of sending continuous analog signal in PC samples of the waveform direct sent, which then converted into numerical value and then they express that the value binary from 0 to 1. This approach was first developed by the L. Krivels in 1937 and it was intentionally used on military and early telecommunications. This key idea, the core concept of the converting continuous time continuous varying signal into digital sequence and that can be easily shared in memory device processed using computer or digital sensor processor, transmitted over long distance without significant of the graduation from the noise. The block diagram of PCM. Analog message signal to low pass filter, then sampling, then concatenator, then binary encoded to parallel to serial converter, then channel, serial to analog connector, then decoder, then reconstruction filter and reconstructed signal. There are three fundamental steps in PCM. They are mainly sampling, concatenator and encoding. Disadvantage: high noise, image, easy to process, secure computation with the digital switching and networking. How many amplitude are there in fig? There are infinite number of amplitude at that the interval is the amplitude of the signal and the amplitude of the continuous is due to these causes of have the connect continuous time, continuous amplitude in the discrete amplitude. Output is only available in multiple of these since Ts is constant, so the time axis discrete time has variable in n. Quantization. To discrete the amplitude was use a quantizer, but why do you use unlimited into signal to going towards but the amplitude of signal in still continuous the uncolored taking amplitude to discrete time intervals. The quantizer class Battle class field uniform quantizer, non-uniform quantizer. Uniform quantizer has two types, mid-trace and mid-trace. Transfer others YT and XT. We can see that the output was 0 when the IP is 0.52 plus 0.5 and output is 1 when between 0.5 to 1.5. Output is 2 when the between is 1. Greater than 1.5. Encoder. Encoder is a block is the converts the quantizer value into binary code for digital transmission or storage. Each binary contain level. The level sampler to quantizer, then encoder. Levels of quantizer. If a quantizer has 4 levels, encoder needs 2 bits for each level. If quantizer has levels, encoder needs a bit for each level. If a quantizer has been 2 levels, encoder needs 2 bits for each other levels. No of bits net equals to log 2 equals to log. Quantizer noise. Difference between actual submitted value when is the transmitted noise. We can see that the output was 0. The continuous keeps high. Maximum signal amplitude equals to Tx and minimum amplitude signal amplitude 2x peak to peak amplitude. The final encoder of the minimum continuous error is E max to pi by 2 unit volts. Uniform distribution and quantization. For uniform quantization error is uniform distribute in range pi by 2. SQNR in terms of bit 4 equals to 2V. SQNR equals to 3 into P by 2 into V. Thank you, sir.